Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 997 that says find the town judge. So here you are given a town where n people are staying and the n people are labeled from 1 to n. Further, there is one town judge in the town. So for a town judge to exist, the town judge must hold two properties. That is, the town judge trusts nobody, means that judge wouldn't trust any person, and further everybody except the town judge trust the town judge, but all the other people will trust the town judge. So if this two property holds for a person, then that person can be told as a town judge. There is exactly one person that satisfies the properties 1 and 2, and for this trust definition we are given one trust addend where trust of I equals to AI comma BI, that represent the person AI will trust the person B. Okay, and we need to return a town judge if it exists, else we will return -1. So now let's take a look at the example here. So here we have two people, and because n equals to 2, and this trust addend. So this trust addend 1 comma 2 represent the person 1 trust the person 2. So all the person 2 means all the person except person 2 trust person 2, right? That means only person left is 1, so 1 trusts 2 and 2 trusts nobody. So both this condition is satisfied here. That's why we can say 2 is a town judge, correct? Now similarly in this case, the person 1 trusts person 3, person 2 trusts person 3, but 3 don't trust anyone, so 3 is a town judge. Similarly 1 trusts 3, 2 trusts 3, and also 3 trusts 1. So there are no person that is trusted by anyone and that person don't trust anyone. So here it is -1, because if you think of 3, but 3 trusts person 1, and if a person to be told is a town judge, he must not judge anyone, okay, in a town. So you can say person 3 is a town judge. Now let's take a look at one or two more examples for better understanding. So here I have taken n equal to 5, that is there are 5%, and this is the trust addend. So yeah, person 1 that we represent as like this way: person 1 trust person 2. So this is the trust edge. 1 trust 2, now here 2 trust 3, 3 trust 4, and 4 trust 5. So this is how this trust I represent here. So this is a trust, each has represented trust. So you can see the person 5 don't trust anyone, but does all the persons here trust person 5? No, means 1 trusts 2, then 2 trusts 3. This doesn't mean that 1 trusts 3. So it is like this way: if 1 trusts 2 and 2 trusts 3, then this doesn't mean that 1 trusts 2. No, it is not. Sorry, it doesn't mean that 1 trusts 3. No, it is not like that. So this is why here, if you see in this example, we would return -1, as there is not a single person that is trusted by all. That's why we return -1. So if you take a look at this example. So if a person, here is a person 1 that trusts person 3, person 2 is that trusts person 3, person 3 is that trusts person 4, and person 4 is that trusts person 5. So here also there is not a single person that is trusted by all other people of the town. So we will return -1. If we would have some situation like 1, 5, 2, 5, 3, 5, 4, 5, and 5, 5. See, 5, 5 is not required, so I'm just erasing this. Okay, so if this is the situation, then what we see here: 1 trust 5, 2 trust 5, 3 trust 5, and 4 trust 5. That means all the people except 5 is are trusting 5, and 5 trusts nobody. That's why we can say that here for this example 5 is the town judge. So to solve this question, there are two approaches, and one approach is using map. So the first approach is using map, and second approach is using graph. So here in this video we will discuss graph approach, because map approach is simple. So yeah, what we will do, we will directly see the approach for the map and understand the approach for graph. So as you can see here, these are all the graphs, see, because they have nodes as well as edges. So what you see, one thing in common to have a person to be a town judge. So for a person to be town judge, uh, we have two conditions, that there must be n minus 1 people trusting him, trust person, and there must be 0 that he or she trust anyone, trust other. Okay, so for based on these two conditions, what we can say, that there must be n minus 1 in degree. So in degree is the number of edges coming inside or coming towards the node. So here for this node 5, the in degree is 1, 2, 3, 4, that is n minus 1, and out degree is 0, that is 0 out degree. That means number of edges going out of the node must be 0 to satisfy this two condition, right? So here, as you can see, there are no nodes going out of 5, thus the out degree is 0, and number of nodes coming to 5 is n minus 1. So thus the in degree is n minus 1. Since now both these two conditions satisfied, we can say phi is the town judge. If you try to check this condition, in degree and out degree, as in other cases, so here let's say for 3, in degree is 2 and out degree is 1. So this is 2 is not equal to n minus 1, 1 is not, and this out degree is not 0. So we can't say 3 as a town judge. Similarly for 5, in degree is 1 and out degree is 0. So there is in degree is not equal to n minus 1. So we can't say phi is a town judge. That's why when there is no town judge, we written minus 1. So I hope you guys understood what is in degree, out degree, and why this based on this two condition we will check in degree and out degree. So now let's move on to the coding part, where we will discuss how we will solve this question. Okay, so one possible solution would be, I will show from here, that you use unordered map, as I told you earlier, to unordered map trusted by and trusted to. So if trusted by, that means a person is then this will store all the person, let's say 2, there's all the person that is trusted by 2. And trust 2 means trust 2 will store the array or the set of persons that 2 trust. Okay, so if a trusted by of I, the size is equal, means it's greater than equal to n minus 1, and trusted 2 is equal to 0, means that person don't trust anyone, and that person is trusted by all n minus 1 people. So in that case we will get our answer. Got it? So now I will show you the graph approach, that is using the in degree and the out degree. So for that, I will create two vector of size m, that is in, and I will store 0 and out, that represent the in degree and the out degree. Now we will traverse this trust array, and we will make here a is equal to t of 0 and b equals to t of 1. That means, and b, it means that a trust b, thus in degree of b plus plus and out degree of a plus plus, because there is an h from a, because for a to trust b there is an h from a to b, so out degree of a plus plus and in degree of a plus plus. That is what we did here. One thing to take care of, here we have 1 to n people, so for that we will create this arrays of size n plus 1. Now let me initialize the answer variable as -1, and we will traverse all the person from 1 to n and check for in degree and out degree. So if in degree of a person I equals to n minus 1 and an out degree of a person I equals to 0, then we can say we got our answer as I, and we would return this answer. And whenever we get our answer, we would break, because there is only one town judge. There cannot be multiple town judge. So let us now try to run this solution, and let us try to submit this. So yeah, our code got accepted. Now talking about the time complexity. So time complexity for this solution is big O of n, as well as the space complexity is big O of n. So you can more specifically, the space complexity is big O of 2 into n. But yeah, overall you can say the time and space complexity both are big O of n, as we are traversing for n elements and storing the n elements. So that's all for this video. If you guys understood the solution and like the approach, then make sure you hit the like button and subscribe to our channel. And if you have still any doubts, then do let me know in the comment section. Thank you.